the next person can understand, it is just as good. In other words, you don't have to spend much time to think about, should I put a semicolon here? Should I put a comma here? Do I use this word instead of the other word? What if I miss a then? Okay, let me just go back to the pseudocode here. Okay, if a programmer decides to miss this THEN, as a keyword, it doesn't change the meaning of this logic at all. Okay, and that means you don't have to spend time to deal with the syntax nearly as much as when you have to program in a real programming language like C or Python or some of the other programming languages. And that's why I use pseudocode in this class, because I want you guys to focus on the logic and not the syntax of the logic. Okay? Any questions? No questions? And that ends the this particular module. We are not done yet. We still have 6 minutes to go. So what I'll do, this is really a wishy-washy kind of module. It's really hard for me to come up with questions for this one. The next ones, will be more to the core of this class. So we'll go ahead and get started. We won't be able to finish everything, but I can at least get started with this topic. So we are now moving on to topic 2. Topic 2 will actually start to get into pseudocode, the way we represent logic in this class. And the first module is variables, assignments, expressions, and sequences. In other words, this will be your reading assignment for this week. If you have time, go ahead and read this module. If you have questions, write down your questions, and then next Tuesday, bring the questions back here and ask me in the class if I don't cover those topics in the class. So what we'll do is we'll just start with a simple task that I want to perform, and I will write it out in English first, and then we'll take a look at the pseudocode equivalence of the same logic. Now obviously this is a really, really old-fashioned way of doing things, but we'll just kind of take it as an example. When I get my credit card bill every month, what I do is I will open it up and I will say, okay, let's assume the balance is X dollars. Okay, so I use X to represent the actual balance for that particular month of that particular credit card. The first thing I will do after opening the credit card bill is to write a check of that amount to the credit card company. So this is assuming that I don't want to have any debt on the credit card, which is a bad idea. So I will pay off every month using exactly the same amount that is on the bill. The next thing I would do is I would try to keep track of my bank accounts as a checksum. I would actually do my separate calculation just in case the bank makes a mistake. I will be able to spot it. So I would keep track of that by subtracting the same amount from what I know would be my available funds, my cash accounts. And if I want to keep track of how much money I have spent using a particular credit card, I would add the same number to the total expense for that credit card for this year. I can do this. I might want to do this for a variety of reasons. If I have a gas card, a gasoline card, I can now track how much I spend on gasoline, because if I only use that card for gasoline, then at the end of the year, if I have the total expense, then I know exactly how much I pay for gasoline. Okay, so those are the things that I want to do. The next slide introduces the concept of a variable, which is the very, very basic concept of programming, is to understand what is a variable. A variable, as the name implies, is an object that can hold a value, but the value can change over time, and that's why the name is called a variable. Every variable has a few attributes. The first name is a name. Okay, every variable has a name that is unique. So that makes it easy to refer to this variable versus that variable, because I can just name the variable and I know exactly which variable I'm referring to. The second one is type. We'll just kind of not talk about the type at this point. We'll just skip to the value or the state of a variable. The state of a variable is basically what value is the variable holding or storing or representing at a particular time. So let's go ahead and take a look and use our example to try to illustrate it. In our example, x is a variable. Let's go back to the previous slide. Why do you think this x here is a variable?
Because it changes every month.
It changes depending on the month. Okay, very good. And what is the name of this variable? That's kind of a trivial question. X, okay? The variable name is x. And the value of x is the amount is the amount on that bill. That's the value of x. Okay. That doesn't seem too hard. What other variables do I have in this example? Well, my available funds, which is, I can personally or manually keep track of how much money I have in a checking account, that's also a variable because this amount will change when I get my paycheck. It will change when I pay bills. Okay? It will change when I have interest accrued on a savings account. And that's why available funds is representing a quantity that will change over time. Okay? If I keep track of expenses through my American Express card, then the AE total expense amount is also a variable because it will change over time. Okay, now that we have these terms defined, we can talk about expressions and assignments. We have about a minute left. Okay, so this will be a good time to kind of finish this discussion, and then you guys should read ahead of me, and just finish this module if you can. This is how I express. Okay, let's deduct X amount from my current available funds to become my future available funds. In other words, if my bank has $200 and my credit card bill is $40, then it will change from 200 to 160. Okay? This is an assignment statement. Okay? This is what we call an assignment statement. The way you look at an assignment statement is it has a right-hand side and a left-hand side. The left-hand side tells you what variable are you updating, what are you changing. The right-hand side tells you what is the new value of that variable. Okay? And that makes it actually not very intuitive because the way you read an assignment statement is not entirely from left to right. What you have to do is to evaluate the right-hand side first. The right-hand side, when you evaluate it, will give you a value. If I have $200 in the bank right now and my credit card bill is $40, then you have 200 minus 40. That gives you a definite value, which is 160 in this case. The question is, what am I doing with 160? Well, this value, which is 160, is used to update the one on the left-hand side. The left-hand side is available funds. So that means my available funds will be updated to become 160 after this statement. Okay? Just one more thing. I know it is already time to go. Let me just use the whiteboard in this case. A lot of people ask, why don't I use the equal symbol to represent assignment statements? In other words, what's wrong with this statement? I want to decrease x by 1, so I can represent it as x equals x minus 1.
You're saying they're the same. You're saying they're the same.
Well, it depends on...
X equals x minus 1 is false.
It is ambiguous. Okay? It is ambiguous. In programming, the equal symbol means assignment, which means the same thing as a left arrow in my representation. But when you take this and ask a math professor, what do you think the math professor will say? Or respond? The math professor will probably laugh first and say, that's not a very smart question, because x can never be the same as x minus 1. Because in mathematics, this symbol, the equality symbol, means it's a statement. You're saying that x equals to x minus 1. Okay? Unfortunately, in programming, we also have situations where we have to compare two values. In other words, If I use the equal symbol in this place here, I will have caused ambiguation later on. So that's why I do not use an equal symbol here. I use a left arrow symbol to make it very explicit. You evaluate the right-hand side, whatever the value of that is, you use it to update the left-hand side. So I'm going to stop the lecture right here. And please go ahead and read ahead of me, finish this entire module. If you can get into Moodle, you can access it.